Today we are talking about lighting for beginners. I will tell you all the necessary settings for each of the lighting sources available in Unreal, and later, at the end of the video, we will use them in practice. Let's go! So we have a completely dark scene. There is no lighting here. And on the left, in the Place Actors panel, we can find all our possible lights in the light section. If you don't see this panel, it is also duplicated. Right here, light. But if you want your Unreal to look like mine, you can go to Window, load Layout and set the classic layout of all windows like in Unreal Engine 4. I've gotten used to working this way over many years, so it's more convenient for me. You can set it up like mine, or all the lights we will be pulling out are duplicated right here. And we'll start in order. In Unreal, there are generally two types of lights. These are point lights, which have a limited range, and those with an unlimited range like the sun and skylight. Let's start with them. The first is the directional light. It simulates the so-called sun. We simply drag it into the scene and we see that now, without any settings, we already have lighting, including global illumination, meaning our shadows are not completely black. Light is already reflecting, everything is working, so Lumen is already enabled by default. And we already have quite a good image. Let's go through the settings. At the very top of the Details panel, we have positioning, meaning location, rotation, and scale. And we can adjust our sun using the rotate function to set the angle of our sun, both horizontally and vertically. We will skip mobility. In Unreal, there are two methods of lighting. One of them is dynamic lighting, meaning as we have it now, we can see what happens in real time. The second method involves baking the light. We will not discuss it today. A separate video will soon appear on the channel explaining how this is done. In our case, we simply set it to movable, meaning movable light, fully dynamic. And any of the light sources we will use today will have these same settings. That is, as soon as you drag any light source into the scene, you click movable and forget about this setting. Next, we have the intensity. It is responsible for the intensity. Next, we can change the color of our light. Source angle is responsible for the angle at which our sun shines. By increasing this parameter, you may notice that the shadows become softer. We can also use, in addition to color, temperature. Warmer, cooler. The Affect World checkbox turns the light source on and off. Cast shadows accordingly eliminates rejection. Shadows. Indirect lighting intensity is responsible for the amount of reflected light. That is, without increasing the intensity of the light itself. By increasing this parameter, you can see that both the shadows and the reflected light become brighter. Let's crank it up to something large. Let's set it to, for example, 10. You see the lighting itself hasn't changed, but there's more light in the shadows. Don't overuse this setting, because your renders will start to look quite flat. And we'll talk about the next setting, volumetric scattering intensity, at the end of the video. So, this is how our sun looks. Let's delete it. And the next light source, which also has no limitations in lighting range, is the skylight. In general, skylight is a bit different from all the others. The rest of the light sources, because it has two methods of operation. The first of them, when we place it in the scene, it starts photographing everything around, and after that, it projects it as if we inserted a regular HDRI map into it, but it reacts to everything happening around it. And for this, we need to check a box in the settings. Real-time capture, meaning to capture everything around in real time. By simply checking this box, we see a notification message that indeed appears, indicating that for it to successfully capture anything, it needs the necessary clear, open sky. So we look for sky here. we have sky atmosphere, and by pulling out sky atmosphere, we still won't have anything because we don't have a sun, which will illuminate the sky for us. Therefore, the skylight doesn't work without the sun. Let's add a directional light, and we see that the sky appears and our skylight immediately starts working. So there is a checkbox affect volt. When we turn it off, we see that the shadows become just darker. By enabling skylight, we see that the color of the sky is added, and all the shadows are also illuminated with the help of skylight, which takes information from this sky. It is quite clear, which is why we get such a bluish tint in the shadows, if we add clouds, for example. Pay attention to the shadows. As soon as I add clouds to the scene, the shadows become grayer because the clouds cover a bit of the sky. It becomes less blue, and the skylight immediately reacts to this. Let's go through the skylight settings again. As I mentioned, it operates in 2 modes. Right now we are looking at the first mode, where it captures what is around. In this mode, we basically, all the settings that will affect it include color. You can mix in another color. As we can see, we make it red, and red appears in the shadows. And the intensity of the skylight itself too, let's set it to 10. We see that the light in the scene has increased significantly. Also, the standard checkboxes affect world and cast shadows. They will be similar in all lights. And the same values for indirect lighting intensity, meaning to increase and reflect light. Also, volumetric scattering intensity. We will talk about it at the end. And let's consider the second lighting option. For this, let me remove the sky atmosphere. Remove the clouds and remove our direct light. That is, we will leave only the skylight again, uncheck real-time capture. And here we have the option for the second mode. The second mode is called SLS, Specified Cube Map. What does this mean? It means that we gain access to a slot where we can insert our HDRI map. This simulates lighting using an HDRI map, similar to what is done in 3ds Max. Let's take an HDRI map and place it in the slot. And we see that we have achieved lighting using this kind of HDRI map. It projects our scene, our lighting. Of course, we don't have anything in the background, meaning our sky remains black. We need to set some kind of backdrop, but all the lighting is happening due to this HDRI map. And now these next settings start to apply to this map. Using source cube map angle, we can rotate. As you can see, the shadows rotate because there is also a sun in our HDRI map. And we see that when I move this slider, the shadows rotate. That is, we rotate our map using source cube map angle and cube map resolution. We set how large the resolution we see in reflections and calculations is. So let's pay attention to the chrome sphere. Set it to 2048 here. Press enter. And our lighting will start calculating in more detail because more information will be taken from the HDRI map itself. And we can also mix the color, intensity, and all other settings also work together with the HDRI map. This is how our skylight looks. Let's delete it. Let's move on to the rest of our lights. The first one will be the point light. From the name, we understand that it is simply a point, a dot meaning a light bulb. Roughly speaking, it emits light in all directions like a regular light bulb. And let's go through the settings. We also set it to movable right away. We have intensity, increase, decrease. We have units of measurement. That is, we can input intensity in candelas. In lumens and some other units, I always use the default. We also choose the color. And for all 3 light sources, which are limited, as I already told you, there is the attenuation radius setting. What is this? This is how far the rays of this light reach. Currently, it is set to 1000. That is, this is 10 meters. If we set it to 100, it will result in our bulb illuminating only 1 meter. But it is currently more than 1 meter away from any object, so its light doesn't reach anywhere. As soon as we get closer to the floor, we see that the sphere shows the range of this light fixture. And when we start coming into contact with objects, such as those with this radius, they will receive light in the environment. A very important setting, which will also be in each of the next 3 lights, is this source radius. Currently it is set to 0, meaning our light. It's simply like a point in space. That's why our shadows are so sharp, because the smaller the light source, the sharper they will be, shadows. If we remember that when we see a huge softbox, for example, in a studio where photos are taken, it always casts soft shadows. It works similarly here. If we increase the source radius, for example, set it to 15, we see that our shadows automatically become soft and blurred. We can also use the temperature to make the light cooler or warmer. And then the standard 2 checkboxes, Effect World and Cast Shadows. And also the intensity of reflected light and volumetric scattering intensity, which we will discuss later. Now we will move on to the spotlight. This is a similar light, but it works like a spotlight. It has a point from which it shines in a cone shape. The settings will be similar, except there is an additional setting for the angle at which this cone shines. And the last most interesting one is the Rect Light. It simulates a square-like, you could say like a softbox, which we can adjust in width and height. Here we have source width, source height, and again, the larger the light source, the softer the shadows. As you can see in this case with these 2 settings, we change its size, and our shadows respond immediately to this automatically. There are also additional settings here. We can change the length of these barn doors and their angle. The light can be more directed or more diffused. Also, in the Rect Light, we can use a texture that it will illuminate with. There is also the temperature. And all those standard settings that we have already seen in previous lights. And lastly, we have the HDRI Backdrop. By default, you will not see it. To enable it, we need to go to Settings, Plugins, type HDRI in the search, and we will get the HDRI Backdrop. Check the box, Unreal will ask to restart, you restart, after which the HDRI Backdrop will appear here. We drag it into the scene. I will lower it or raise it slightly, because it coincides with the floor of my scene. And we get, this is indeed a kind of combination indeed, of a skylight, along with ready-made geometry, so that we have an image in the background. In order for our scene to start retaining light, we need to adjust the size of the backdrop here. Increase it a little. I will set it to 2000. And you can see that our scene has started to retain light from this HDRI map, and we can already see the desired image in the background from it. We can also adjust the projection of the HDRI map using this projection center. Select it, and by moving it up and down, we change the perspective of the HDR map, and we can set it so that it looks good in our cameras. There aren't many settings here. Increasing the intensity gives us more light. The size of the backdrop itself. If we select the background and press the F key to center on the geometry, we will see that along with the HDMI backdrop, we show a simple geometry of a hemisphere with a texture stretched over it appears in the scene. Let's return to our people. And we see that we immediately got ready-made lighting, like a cloudy day. And we have, by selecting our HDMI backdrop, a slot for the HDMI map. Similarly, we take and insert the required map. And we get lighting from this map. You can adjust the angle simply by selecting the backdrop itself and rotating it. The lighting response to the position of the HDRI backdrop itself. The only thing I would advise you is not to use only the HDRI map for lighting, both in the case of skylight and in the case of the HDRI backdrop, because this is a game engine and it calculates light in a somewhat simplified manner. In the case of HDRI maps, for example, if you take an HDRI map in which there is something like a bright sun, and it will cast such super sharp shadows, then in 3D Max Corona, it will calculate these shadows as sharp. And in the case of Unreal, this same HDRI map, let me demonstrate to you. I will lower the ground a bit so that we have a gray plane on which we can see. You see, the shadows are quite blurred. If we turn on the path tracer, we will see that the shadows are indeed sharper. In a calculation like Corona, in the case of real time, we get these more blurred shadows. Therefore, I would use HDRI maps, whether in the case of backdrop or skylight, in conjunction with some sources of light. In this case, we can add direct light here, set the angle approximately as we have on our map, and simply adjust our settings, even set it to 0.2, 9.5. Maybe I'll make it a little warmer, and we get a nice result. And the lighting will look much better and more detailed. And now I'll show you how to very quickly and easily set up the settings in your scene. Let's delete everything we have. Go to Windows, Environment, Light Mixer. Open it. We get a window like this. And to add the Sky plus Sun system, we don't need to pull out the Directional Light skylight, then look for clouds, look for the sky to gather information from. Skylight. For this, we have an Environment Light Mixer where all we need to do is click. 4 or 5 buttons, 5 if you need clouds as well. Look, this is how it looks. Click on Create Skylight and a skylight is created in the scene. Click on Create Directional Light and a directional light is added. Create Sky Atmosphere and we have the sky. And here, if desired, we can also add fog in the background. And clouds if needed. Clicked. That's it, we have fully configured lighting in your scene. And now, by holding Ctrl+L and moving the mouse, we can adjust the lighting as needed. And you can configure all your lights, or here, by selecting them by default, as you would typically change them, or in the Environment Light Mixer. You can even attach it here in the panel. Here you have the option to show either the minimal, the most basic settings, or of course, even advanced settings, meaning all advanced settings will be open. And you can see, here we have Directional Light has all its settings. To the right is Skylight, all your lighting is gathered in one place and it's very easy to adjust here. And now let's move on to practice. For this I will open a new scene. As you can see, it is completely without lighting. For practice, we will use a ready-made scene from Quixel Megascan. It's called a saloon interior. You can download it for free. And if you wish, you can follow along with me. And let's use the same Environment Light Mixer so that you understand that it works, not only for exteriors but also for interiors. It can really give us a pretty good start. Illuminated. We go again to Windows, Environment Light Mixer, open it, click, Skylight, Directional Light, Atmosphere. As we can see, some light is already starting to appear. And then we can add clouds if we wish. Well, let's add fog as well. Here, we have all our settings gathered in one place, but to see them better, I will change them here on the right. Here we have the volumetric fog settings, make sure to enable it, then our fog is calculated physically correctly. And now, using Ctrl-L and mouse movement, we can simply locate and set the sun in the interior of our 3D model. As we can see, we already have a pretty good initial rendering result to start with, which is quite promising. We just need to change a few specific rendering settings to achieve the desired effect and enhance the overall quality. The first setting that needs to be changed is the automatic exposure. Why? Because right now, when we look at the bright parts of our interior, like the windows, we have one exposure. As soon as we turn to the darker part, it changes, and it will fluctuate back and forth, changing. We don't really need that. For this, we need to bring a post-process volume into the scene. We search for post, bring it into the scene. Go to the settings section. Here we have a checkbox for infinite extent unbound. We check the box. What does this do? This makes the post-process volume extend across the entire scene, throughout our entire world, without limitations. By default, without this checkbox, it only works when we are inside this square. We go up to the settings, find the exposure, and here we have exposure compensation. And there is also a minimum and maximum. Let's set the minimum and maximum to 0, so that the exposure doesn't fluctuate. Now we've locked it in one place. And we can now increase the compensation, as we absolutely need, and it won't change relative to the camera movement. I think an exposure of 5 or 5.5 will be sufficient. And as you can clearly see, we have indeed successfully achieved a very well lit scene, with just a mere 5 mouse clicks. And to demonstrate to you that it works practically on every scene, there is just another ready scenario nearby, which we enter and see that our lighting fits perfectly. And here, all we might need is a little to tweak the exposure. Also, since it's a kind of cowboy saloon, I would add a little bit more dust here, perhaps some additional dust. And for this, we can select our sun, the directional light. And we will return to that setting I mentioned at the beginning, which we will look at in the end. This is the volumetric scattering intensity. What does it do? After we enable it in our fog, that it is, volumetric fog, begins to take effect. Here is this setting. By increasing it, these light rays that you see now will become brighter. I will raise the value to 10, and you will see how it works. This is of course too much, but it's just so you understand what it is responsible for. And in our case, 3, even 2 units will be enough. And it immediately looks like there's quite a bit of dust in this interior. And the lighting, in my opinion, looks great. And at the same time, let's try the second option. What will we do? We will delete everything we added. That is, we will delete the directional light. We will delete the skylight, atmosphere, and clouds. We will leave the post-process to lock our exposure. We can also delete the fog. And we'll try using an HDRI backdrop for lighting. Just drag it into the scene, as we've done before. I will lower it slightly below the floor so that it doesn't conflict with our parquet board. We will increase its size to 2000. And as you can see, we already have a decent result. The only thing is you might notice the ceiling. You can see that for Unreal, one HDRI map provides a bit too little light, especially when we have such relatively small windows, and this results in some noise. This is exactly the case where you can add some directional light or any other light sources to help the skylight, or HDRI backdrop. In our case, let's use a Rect Light. We take our Rect Light, rotate it, and place it somewhere in the area from where our light should be coming. Set the values to something small, like 0.3, maybe 0.5, and slightly increase its height. As you can see, the number of mega shadows has already decreased here. Let's duplicate this, Alt, drag it to the window. Here you can slightly reduce it, so it doesn't intersect with the geometry. Duplicate it. These two can be reduced to 0.2. I would reduce them. And we still have many windows at the top. Let's Alt-Chi drag them upwards. We'll pull them slightly away from the wall and duplicate them here. As you can see, all the mega shadows have disappeared. Maybe there's a bit too much light, and we can adjust them, even reduce them to 0.1. There. And we have achieved a completely different lighting option. Using an HDRI map, it's like a cloudy weather. Perhaps, I don't like being here either. A bit too much light. And I'll also add one more point. If you have any reflective surfaces, your lights they are visible in them. To remove light from reflections, for example, right now in the floor, this puddle clearly shows our light. We select the light and look for specular in the settings. And this specular scale, if we set it to 0, you will see that it disappears from the reflections completely. Our light. This way, you can, in a manner that is both effective and efficient, brighten up your interiors or exteriors, and also hide the light, so that it is not visible in reflections. This is roughly how lighting looks in Unreal Engine. There is nothing complicated about it. The main thing is to know the tools we are working with and their settings. Subscribe to the channel, comment, and ask questions. I will try to answer all your questions. And see you next time.